Okay, in number 3.5.6, the given situation is there is a 5 feet tall woman and walking to the toward the street light. So there is a street light, okay, and toward that light, okay, that's one of the big information, and there must be her shadow. Okay? So this portion must be her shadow, and this is straight, okay, like that, and with the rate of 8 feet per second. But look at here, assumption is that the height of the light is 20 and she's a 5 feet, and let's say this is the length for the remaining distance. Then she walked toward that light pole, so it's 8 feet per second, but that should be the rate of change of x, right? Then right now x is shrinking, so it must be -8. That's the kind of most common mistake, right? Missing the negative there because it's shrinking. Then we are looking for how fast her shadow is kind of changing, right? So what is the rate of change of the length of a shadow? Okay, so let's say that shadow is s, right? Okay, that's the length of it, and of course the rate at x becomes 15, but let's just worry about that one later. Okay, so do not use this number at this moment, right? Then because of this given situation, let's just compare this big triangle and this small triangle. They're similar, right? So they have to have the same ratio. So from the big triangle, the base is x plus s, right? Whatever it is. And compared to the height 20, must be same rate to the corresponding size of the small triangle, which is s over 5, right? So when you multiply 20 on both sides, it's x plus s equals 4s. So 3s must be x. Okay, so that's the relation between x and s. Now we are looking for what is the rate of changing of ds, I mean s, right? So it's going to be ds dt. So take the derivative on both sides with respect to time t, then it's going to be 3 times ds dt. Now that is -8. So ds dt must be -8/3, of course, feet per second in this case. And it's reasonable because when she walked toward that light pole, then her shadow will also kind of shrink, right? So this must be the right one. And because of the nature of the relation between x and s, the given condition like when x becomes 15 actually doesn't mean anything, because the rate of changing of her shadow is always just the same, okay, no matter where she is, right? With that speed, her shadow is going to shrink down, okay? So the answer should be that.